start here. So where we left off last time is I talked about elasticity. And elasticity is really just another word for sensitivity. And it's a reaction. Okay, that's elastic. This gives you a degree of a reaction. So if somebody's very sensitive, then they react a lot to whatever the situation is. And that's how elasticity is. It's very sensitive, and they're going to react a lot to change. So, if you say something like a little bit, negative to somebody, then some people will react really negatively, like you just, ran over their dog or something. And what this is, so that would be a sensitive is just another word for elasticity. So something that's elastic, something that's it reacts very sensitively. So what are we talking about that's changing? So what's changing is the price of the good, and what's reacting is the quantity demanded. So that's the difference here. So the change is going to come in the price. So we're looking at this equation, and this equation is just here with this QX, and this QX, in our case, the QX means the quantity demanded. That's all we're looking at now. And later on, QX will mean the demand, or the amount sold. But for right now, this QX is the quantity demanded, and the PX is just the price of the good. So the PX is the price of good X. So we said that there's a negative relationship. So when this price changes, it's going to cause a reaction and a change in this quantity. Does that make sense? Okay, so the price change will cause a change in the quantity. And it could be something like, well, let's just say we have this price goes up by, a little bit like that. So that would be an increase in price. Then what happens to the quantity? Well, the quantity could go like way down. So here's my, so this would be like a little change in price. It goes up by a little bit, and everybody rushes away from the product. Okay, excellent. So that would be an example. Okay, an extra shot here. Big A one. So the change here is pretty extensive. So this would kind of be the picture of, the picture of elasticity. That would be elastic. That's a good that's very, very sensitive. So a little change in price causes a big change in the quantity. So that means if they raise the price by a little bit, you're just not going to buy it anymore. You'll find something else to buy or whatever. Now, it could also be something like this, where a little change in the price, or let's make it even more extensive. We have a big change in the price, and it causes a little change in the quantity. Oops, they go in opposite direction. So notice they go in opposite directions both times, but this time it's very insensitive because we have a big change in the price, like they increase the price of cigarettes from $3 a pack to $10 a pack, but people keep buying them. Not as many, right? I mean, there's going to be some impact to that. And in the cigarette market, the impact tends to be with the younger kids. The teenagers tend to not buy the cigarettes as much when the prices go way up. So really what it does is it stops people from starting smoking when cigarette prices go up. So people who currently smoke pretty much continue to smoke. They just pay more money for it, and they give up something else like eating, right? Because they got whatever, right? Maybe buying a different type of car, right? Because really, it gets to that point where if you're spending a lot of money, you can just say they were $12 a pack and you're smoking a pack or two a day. That's $12 times 30. That's a car payment, right? $12 a day times 30. You can get a pretty nice car for $360 a month. That's a lot of money to spend on cigarettes. So you have to be giving up. Or what happens with older people is they do give up something else. But they don't give up their cigarettes. And that would be an example of inelastic. So now you kind of have that framework, and you kind of remember what it's like. Now the graphs for this look like that. So for the elastic graph, we have this price here, in this quantity here and said that there's a, so it's kind of like that, right? Where there's a little change in the price causes a big change in the quantity. So see, the price is going from here to here, and the quantity goes from here to here. So that's, see, this is little, just like my line here, and this is big, just like my line here. So it's going in the opposite direction, right? So it goes, when the prices go up, the quantities go down, okay? Or vice versa. Okay, so this graph goes along with this picture, and hopefully you get the meaning of what I'm trying to do here. Now this one here, the elastic graph, will be more like this, or inelastic graph, would be more like that, and so the picture that goes along with these words, and we have a pretty big change in price. Let's just say, keeping with our cigarette example, they go from $2 to $10, and the number of packs that people buy go from 6 to 7. So there's a big change in price, right? The price goes way up, and the quantity only goes down by a little bit. So this is my picture that goes along with this. This is my inelastic picture, and this is my elastic picture. Everybody okay so far? So that's basically a review of what we did last time on elasticity. Okay, so now what we're going to do is we're going to actually calculate elasticity. And what elasticity really is it's the measure of, so the elasticity that's EP is going to be what I'm going to just, so whenever I write EP, you're going to know that that's the price elasticity. So this is the our price elasticity. So we're going to solve for EP. So EP is the percentage change in QX over the percentage change in EX. So what happens is this change, there's a change in the price of PX, there's a change in the price, and that causes a change in the quantity. So if you go over here, I don't know if you guys, can you guys see that, or is it too much glare? Can you see that? Okay. So this here, and this here, and this here are the same thing. Now the only difference is we're looking at percentage changes. So if there's a 1% change in here, it's going to cause a 3% change here. So that's so that you can kind of interpret it better. So the way that so this formula here, and we're going to use this on a demand curve. So let's look at a demand curve, and we have price and the quantity. This is the schedule. So we start with the demand schedule, and we say the price is 40. When the price is 40, the quantity is 10. When the price is 35, the quantity is 20. The price is 30, the quantity is 30. The price is 40. Oops, sorry, 25, 40, 20, 50, 15, and 60. These are on our notes also. So this is a demand schedule. So now we look at the demand schedule, and this here is the demand curve that goes with that schedule. So it's going to look like that. The demand, quantity, and the price. So now I'm just going to plot these points to say this is 40, this is 35, 30, 25, 20, and 50. And then going down, these quantities are going to match those. So it's 10, 20, 30, 40, 50, and 60. So all I've done so far is plotted a demand curve. I just put in these points and I'm plotting these. Anybody, is everybody okay so far? Yeah, we're good? So now comes the fun part. Now we actually get to calculate the elasticity. So what I want you guys to do is make sure to clear some space here. And I actually, we're going to look at the formula. So the formula for elasticity is right here. But to make that a little bit more clear, I'm going to do the change. The triangle is a change. In mathematics, a triangle always represents a change. So the change, if I went from 1 to 2, then the change would be 1. If I go from 1 to 99, the change would be 99. I'm sorry, 98. So 1 to 100, the change would be 98. Okay, so that's just the change in, it's just the difference. So you can subtract the 2 and get your change. So you get your change in QX over your average QX. So I'm just done with this. That's all I did, is the change over the average is the percentage change in QX. Now, since this is below, it's the line, right? So it's the denominator, so I'm going to invert and multiply. So now that's going to be times the average price of X times the change in the price of X. And that's your formula for elasticity. Okay? So you're going to end up memorizing this. You're going to, you know what, if you want me to write this on a test or a quiz up on the board, I will. But by the time we get to that point, you're not going to even need it. Because you're going to practice it so many times that you're going to know exactly what this means. Does anybody have any questions about what that formula is? Yes?
Is that average?
This is average, yep. Maybe it's average, yep. Other questions? I'm going to move this over a bit. I'm just going to move it over here. Does anybody else have any questions before I move forward? All right. So one point was 40 and 10, and the other point was 35 and 20. So I'm going to figure out the elasticity between this point here and this point here. So let's just call this point A, and point B, and point C, and point D, point E, and point F. And so this is my starting point, from A to B. So my question would be to you, what would be the elasticity between the points A and point B? What would be the elasticity? So we have to solve for that. And now, if you already got it, you're doing great. Okay, but here's what you would do. Okay, just going through it slowly. You take your price. Your starting price is 40. And then you go to a price of 35. And then your starting quantity was 10, and you go to a quantity of 20. So this is the information that you need to plug into this formula to solve for the elasticity. All right? And if you want to know why, I'll explain the why later, I promise. But for right now, is that I'm getting interest? Is it this one or this one? Which one's this one? So that helps at all? No.
It's like,
Coming on the side?
Yeah.
So if I still go like this, there's no hope, is there?
No.
Sorry, just sunglasses. Sunglasses in my car. But all right, so this here is just we're going to look through the formula. Let's go through the formula now. It's solid, right? Change in Q. Q goes from 10 to 20. So how much does that change by? So price elasticities. Let's do this. The first part. The change in Q. We go from 10 to 20. So what's the change by? 10. It went up by 10. The average between 10 and 20. 15. This is the number that's in the middle. It's going to be 15. Or you can, if you want to do the average the slow way, you can add these two up and divide by 2. So you could say 10 plus 20 is 30, divided by 2 is 15. Or you can just look at it and go, the number in the middle is 15. That's the easier way. All right? Everybody's okay so far? Yeah? The next one would be the average price of X. Well, here's the 40 and the 35, so what's the average? The average between 40 and 35, 37.5. and then the change, and notice it went down by 5. So we have to be, yeah, it has to be a negative 5. So if you multiply 10 times 37.5 is 375. There's a negative there, 75. So negative 375 over 75 is equal to negative 5. That's it, you did it. Solve for elasticity. All right. Questions? Anybody have any questions so far? We'll do more. All right, let's do the next. Let's just do another one here. And the next one would be, let's try it. Let's try to go from point B to C. So from point B to point C, we go, it would be this information here, where we go from price and quantity. So B is 35 and 20, and C is 30 and 30. Just getting that one right here. Okay? So the elasticity for this one, we do the change in Q. So how much did Q change by? So it went from 20 to 30. So how much did Q change by? It went up by 10. The average Q, 25. The average price between 35 and 30, 32.5. And the change in price, down by 5. So 325 over 125. The negative sign there, so that's equal to negative 2.6. So what happens is when you move along this demand curve, the elasticities actually change. And that's why it's called an arc price elasticity. So we're solving at first for the elasticity here is going to be different from the elasticity here. And the reason is that when, if you think about it, if the prices are really high, and a company lowers their price, it's going to probably make a bigger difference than if the price is low and they lower their price. Right? So I mean, if you think about that, that makes sense. That the elasticity, the higher we go on this demand curve, the more elastic it's going to be. And then when we get down here, it's going to be less sensitive, which I'll show you in a minute. So what does this mean? What does it mean, and what's the value of having a number like that? Well, the main thing it means is you have to go back to this interpretation right here. You have to go back to this formula to understand what you just found. So what you just found out is that you have a negative 5. That's right? Right? The price elasticity equals negative 5. And any number that you get is going to be, you can just put it over 1. Right? It's the same number. So any number that you get is going to be over 1. So what we found out is that a 1% change in the price of X causes a negative 5% change in the quantity of X. That's the interpretation. So if you raise prices by 1%, it's going to cause the quantity demanded to go down by 5%. Right? If you lower prices by 1%, it's going to cause the quantity demanded to go up by 5%. So if you follow along this formula, it's a 1. In our case, let's just say we went from 40 to 35, so we lowered prices. So a 1% decrease in the price of X is going to cause a 5% increase in the quantity demanded for X. And why is that important? Well, it's pretty cool for a company to be able to say, hey, if we just raise our prices, if we lower our prices by 1%, we're going to have 5% more people who want our product. That would be good information to know. So you know in that case, your product's really pretty sensitive to prices. So you got to be very careful. And you have a great opportunity to be able to take advantage of that for people. Okay, you have a great opportunity to do that. So is everybody okay with the calculations? Well, if you keep going down here and you keep doing the elasticities, there's point B, and there's going to be point E, and there's point F. And what will be the elasticity of going from here to from point C to point D. Can anybody calculate that? Or you already do it? So just calculate that one, and it's gonna kind of, I didn't make like all the copies, so I'm just gonna kind of, maybe some of you guys can share them. From C to D, yeah, will be the elasticity. Your calculator? Yeah. Yes. Yeah, I'm trying to like that when some of you guys are going to share, because I don't have yeah, this isn't a quiz. This is we're going to do this right now, class. But it's okay. What was the answer for that last one?
Negative 1.57.
Negative 1.57, right? So that was negative 1.57, and so what these mean, right? So if you're looking in terms of what is something elastic or unit elastic, then think about the number line. And number line, right? We have a 0 and a 1 here, right? Now, elasticities are all going to be on this side of the number line. We're not going to have an elasticity that's going to end up being anywhere like any positive number. So you're always going to get some elasticity, right? It's going to be less than 0. I mean, could it be equal to 0? You know, maybe in this extreme case, people can charge as much as they want and people will still buy it. But the majority of the time, I mean 99.99% of the time, when there's an increase in the price, there's going to be some decrease in the quantity, so that number will be negative. So we just said that the elasticity is negative 5. Anytime the elasticity is this side over here, in other words, if the elasticity is less than negative 1, which would be all of that over there, then it's considered to be elastic. The good is considered to be elastic, price elastic. And if the elasticity is in this range right here, between 0 and negative 1, it's considered to be inelastic. So if you see the elasticity, price elasticity is less than 0, greater than negative 1, then it's going to be inelastic. That would be this range right in here. And if it's equal to negative 1, it's called unit elastic. So those are your interpretations. So if we kind of keep going along our line, the thing comes out like this. Maybe that's a 6 to 8. But up here from A to B, that would be a negative 5, so that would be elastic. Yes, question?
What did you say it was equal to on negative 1?
Negative 1 is unit elastic. So if it's equal to negative 1, then it's called unit elastic. That would mean like a 5% increase in the price would cause a 5% decrease in the quantity. They go together. Okay, opposite direction, but they go the same amount. So you get the same impact. All right, is everybody okay with that so far? Where do you lose it? Right, so here, this would be, when it comes out to be negative 1 in this range here, that's called unit elastic. And when it's down here, it's called inelastic. And why that should matter is because, again, companies are always trying to figure out what price they should charge. So let's just look at this, and I'm going to put another column in here, and we'll call that column total revenue column. And total revenue is equal to the price times the quantity. And another term that we need to know is going to be the average cost per unit. So I'll call that AC. So your total revenue here is going to be just your price times your quantity. So if you go across here and you go, what's my price times my quantity? At point A, what's the total revenue amount? 400. And how about point B? What's the total revenue amount? 700, right? It's just 35 times 20 is 700. 30 times 30, 900. 25 times 40, 1,000. 20 times 50 is 1,000. And 15 times 60 is 900. So our total revenue helps us to kind of understand this whole elasticity concept. Because if we're here, for instance, if we're in the elastic portion of the demand curve, which would be right here, this demand is -5. If the company lowers their price, what happens to the revenue? It increases. So from their perspective, they can bring in more money if they actually lower the price. Okay, now look at it from here. Let's go from the other way up. Should the company charge $15 for this good? Yes or no?
No,
Why not?
because it's 900 is less than 1,000.
So if they raise the price to 20, right, then their revenue is going to go up. And what about their cost? What would happen to their cost here? Can you tell? How do you determine cost, you guys? Well, one of the things you have to look at is how much they're producing. So if their cost, if here they're making 60 units, right? So you're making some product, okay? You're making these little things, these little podiums. And what's going to cost you more? To make 60 of these or to make 50 of these? 60. Okay, so what's going to cost more? Here, 60 or 50? 60. So your costs are going to be higher here, and your revenue is going to be lower here. So now we have to think of our third formula, and our third formula is profit, which is the goal. And the goal for the company is to maximize your profit, and you take your total revenue minus your total cost is going to give you your profit. So how do we figure out the total cost? In our example, we're going to say the total cost is equal to the average cost times the quantity. We have it. I haven't put in an average cost yet because I don't have to. I don't have to yet. Look what would happen here. If they raise the price from 15 to 20, we know that the revenue is going up, right? Because it's going up from 900 to 1,000. So everybody see that? If they raise the price, they actually bring in more money. And also, if they raise their price, they're going to produce less, so their costs are going to go down. So their revenue goes up and their costs go down. So that means they're going to be more profitable here at this price than they would be at that price. Would they be better off at point E or point D?
Point D.
Point D. Why?
Just producing less,
Because what happens to their revenue? Stays the same. What happens to their cost?
goes down.
It goes down. How do we know that? Because they're producing less. What would they, now, and that's where it stops, because we don't know next because we don't know cost. But we know that they don't want to charge a price below this. Okay, they don't want to charge a price below 25. That's our, we know they wouldn't charge at the inelastic portion of the demand curve. Because this is inelastic here. We already calculated it there. So this would be negative 0.67, and this is negative 1. So we know, right, for a fact that a company isn't going to charge in the inelastic portion. It wouldn't make sense for them because they can raise their prices and make more money. So why would they possibly charge here when they could charge all the way up here and make more money? It wouldn't make sense for them. So if you're wondering, where does this lead to? Well, a company has to try to figure out what price they should charge. So how do they do it? Do you think they go in the back of their store and they have this demand curve and they go, okay, well, what's the inelastic portion? And yeah, obviously not. They don't do that. I mean, you guys have all worked at companies. Have you ever walked into the back of a store your first day there and they say, oh, what's that? Oh, that's our demand curve. Yeah, we keep this in the back just in case, just because we want to figure out what our prices are. Of course they don't do that. But what they do is they change prices. And when they change prices, they look and they say, hey, we had a sale, a 10% sale. I mean, honestly, raise your hand, guys. When you walk by a store, you're at the mall, and you walk by a store, and you see a sale that says 10% off. What's it do? It doesn't do anything for me. I'm 70% off. I'm like, yeah, I'm in. 10% is like, you just, because, and of course, we all think they just raise the prices by 10% anyway. So what's the difference? 10% off doesn't really do it for us. But they try these different prices, and when they try the price, they look at the quantity and they try to figure out were we here or here. And sometimes these companies will annoy you, and they'll keep doing these these little they'll keep raising the prices, but they're just testing the waters to see if you'll keep buying the product. All right? And again, now the ideal place to be if they want to maximize their revenue would be right here, because revenue is highest here. Look at this, 400, 700, 900, beep, right? 1,000, that's the highest, and then it starts going down again. So if they want to maximize their revenue, they're going to be here in this what's called the unit elastic portion of the demand curve. So but what companies want to maximize their revenue? I don't know. I mean, most companies want to maximize their profit, but some companies, at the beginning, in order to gain market share, do like to maximize their revenue. Right? What's it? Amazon? They probably do. Right? Just try to get the volume so you keep others from entering into the industry. And you see a lot of startup products will do that. A lot of startup products almost give their product away, just so that they can get some market share. And the reason is because we get really attached to some products, right? I mean, when's the last time you guys have changed, let's say, your toothpaste or your deodorant? I mean, if I was selling one of those companies, I'd give it away. I would. My first month in business, I'd be giving it away. People like it, they'll buy it. Not only will they buy it now, they'll probably buy it for a long time. They'll become very, and you'll have a loyal customer. And same thing like with deodorants, that's why when they first come in, they do the same exact thing. And so it makes sense for them to try to gain, to be here. If they're trying to gain market share, that's not a bad idea. But most of the time, that's not what companies do. I do it. I do it with my camps. Right? Because when I do camps, I always try to maximize my revenue because my costs are almost fixed. So, and if I have an additional 10 kids who show up, I'll just make one of my kids work, right? And I don't have to pay them anything because I pay them everything, right? They get everything they want anyway. So I might as well make them work once in a while for it. So I will do this. I'll lower my prices so I can get more revenue. And so I play with these prices a lot for camps. I just did over Christmas break. I did a little camp and I charged like $50 for the camp, and I just was hoping that I would get a lot of kids for it with it. Because I had zero cost for this camp. My camp, I didn't get all t-shirts, I had all the equipment, and the field was free. So I figured $50 would be great. Any money I get, and I was doing it to my daughter, so I decided to split it with my daughter. Okay. So we had like 20 kids, I made $50 a kid. So my daughter made like $800, and I made $200. So that was fair. That's kind of how it ended up being, because she figured I might as well give it to her anyway, so I didn't get it. But that's kind of how it works. In that case, we're just doing this. We're just maximizing revenue. But what would happen here? What happens going from here to here? Well, we have to kind of figure that out. We have to have prices to determine. So let's say that the average price of the unit the average price, or sorry, the average cost of the unit is equal to $20. And let's go $30. $30. All right. No, let me just, I'll go back to 20. Okay, sorry. All right, so if that was the case, then let's figure out, let's just go here at point D. And if the average cost is $20, what I want to do is I want to figure out what their profit is. So we'll say they're charging a price of $25. So price is 25. Their quantity at 20, the quantity there is going to be 40. And I said their average cost per unit is 20. So what would be their profit in this case? So the profit is equal to the total revenue minus the total cost. The profit can be rewritten as the price times the quantity minus the average cost times the quantity. So all you need right here is these three variables, and you can figure out what the profit would be. So what's the profit there? 200. What is it? 200. Okay, so you take total. So price times quantity is 25 times 40, so that's 1,000. And average cost is 20 times 40, so that's 800. So do profit is equal to 200. Would they be better off charging $25 or $30 for their unit, for their product? So what would be the way, how would I answer that question? What would be the, you know the profit is at 25, right? This is the price for 25. What would be the profit when the price is equal to 30? So quantity is equal to what? When the price is 30, the quantity equals 30. And the average cost we said equals 20. So what's going to be the profit here? So the profit is 30 times 30 is the total revenue. So that's 900 for total revenue. And total cost is 30 times 20. So it's 300. So are they better off charging 30 or 25? 30. So when they raise their prices, they actually will make more profit. Okay? Everybody with me so far? And you can keep going and do this. How did I get 600? I took the average cost times the quantity. So the average cost is 20 times the quantity, which is 30. Yeah. And then, so then our profit is 300. So you kind of get an idea of how a company can use this, right? And they need to know what type of what type of product they have in order to make sure they're not pricing down here. Okay, so what I want to do is I would like you guys to come up and do some of these elasticity problems. I'd like you to just do them up on the board. Okay, so I've given you anyone from problems, so it'll be 5 of you that will be selected, or you can volunteer, and you can ask a friend to join you if you want, and you come up to the board and do and here's the deal. You're going to sign underneath it. Okay, so we'll have. Here's how it's going to work, right? You have a question number 1 through 5. So if you want to do number 1, come up. So do you want to do number 1? Anyone? Thank you. All right, come on up. Here's some chalk. You want to bring anybody with you? You can add. See, I waited for my first volunteer, but it's going to be so you can add 10 points to your with 2 test points or 10 quiz points. Huh? Test points. That's your good answer. Okay? Because alright, so 2 test points. But if you get help from anybody, right, then you have to give them one of your test points. So don't get it wrong. If you get it wrong, right? So 2 test points, and you have to sign underneath it, so I make sure I record it. So 2 test points. And if you got 100 on the test, then you should let somebody else get it. Okay, so just trying to be nice. Okay, who wants to do number 2? 2 test points. Yeah. All right, there we go. Emily's going up for number 2. Number 3. On your own, or on your own? You want those points? Okay, come on up. Right? That's Carrie. Yeah. Okay. And number 4. All right, come on up. Number 4 and number 5. Come on. No help from anybody? All right. Kate's got number 5, and we're good. And then you have to explain them, and if you get them wrong, the whole class gets to throw something at you. I love that part. Just choose it. All right, there should be like a few, there should be one of everything. All right. Need some help? Yeah, 1 minute. If you want to get some help up here, get some help. If you're good, you can sit down. Well, yeah, you can explain from your seat what you did. Help on this one. I'm sure you got it. Okay, so while they're doing that, let's just walk through these, okay? So this, I would love to give somebody credit for this, but I don't know who did it, so. Yeah, that's part of the process here. I mean, make sure Yep. So you come up here. Get your point. So we're, the formula is the numbers are right. And what you guys should do if you didn't, just make sure that you can answer all along and keep this like a study guide. But here's the thing, right? When you do these math problems, a lot of times, it looks like it's easy to follow when you're sitting in your seat back there, and I'm saying what's the average of 1 and 2. It seems pretty easy. But going through the formulas and having the pressure on you and coming up here, it's not as easy. So this is sort of replicating a test. When you have to do it on your own, you feel a little bit of anxiety. So that's why we did it here. Just kind of going through. I thought I was like not neat, but this is all over the place. But let's do this first one. When the price leather sofas is $1,000. The quantity demanded is 20. So we have 1,000 and the 20. When the price is 1,200, the quantity demanded is 15. So here's our 2 points on our demand curve. Then just go through the formula. The change in Q is 5. The average Q is 17.5. Then the average price is 1,100. The average between 10 and 12 is 11. And then the change in price is 200. They got the negative sign in there somewhere, which is what you have to do. And then just solve and came out with negative 1.57. Is that good? You guys get that? Anybody check that? Everything look good math-wise? All right, next. So Yasmin gets her 2 points. Okay, on this one here, we have the first one, all the numbers were good, so half the work was done, but the formula wasn't right. So then, so Lily kind of helped Emily with the formula, and here's the result was the change in Q is 50, and the average Q is 175. Okay, the average between 200 and 150, and then the average price between $1 and $1.20 is $1.10, and the change in price was 20 cents. So that's good. And then they multiplied, and I can't see where that is. So multiplied these two. Is that what that's that here, and then we come up with that. Is that good? Does that look good to you guys? I kind of lose it here with 220. I guess that looks right. Yeah. Question?
Does it matter if the negatives on top or bottom?
The only thing that I would do different here is I'd probably put the point. Instead of the 20, it's a 0.2. Right? Because it's only 20 cents. It's like a point, that's a 2. So that would make a difference. That would make this different. And that would move the decimal place over. Because it's a 20, it's a 0.2 here, right? Because that puts it out of scale. So it would be 55, and then then it would be one. So then that would make more sense here to be 170. That would be a decimal place there. It comes out to be like 1.5. So is that good? Anybody get that? Does everybody see that? Or what's your question, John?
The negative should be on the bottom of that.
It's you know what? At the end, make sure there's a negative there. Okay, because some people could say we started here and went here. Some people could say we started here and went here. So it doesn't matter as long as you have that negative in the answer. So that's okay, but that number, that decimal should be moved over here. So it should be negative 1.5. Okay, next one. All right, so 400 and 500, change is 100, average is 450. Average price is $5.50, and the change is $1. Perfect. So that looks really good. Okay. Any questions about that one? Okay. Next one. The average price, the average quantity should be, or the change in the quantity is 20. The average is 330, so that looks good. And then the change, the average is between these two is 8.5, and the change is -3. So that looks good to me. This would be inelastic. Okay? Because it's below that. Any questions? Oh, yeah, everything. Whoever did that, I can't remember now. The next one is, these are the easiest ones. When you multiply these two, like 4 times 8, and 3 times 16, they equal the same thing. Like this is equal to, the total revenue is 3,200 here and 3,200 here. Then you know your answer is going to be -1. Okay, but you can do it. But I didn't tell Tate that till he was done because I wanted to torture him a little bit. But the change here is 800, and the average is 1,200. Then the average is 3, and the change is -2. So 8 times 3, 12 times 3 comes out to be 2,400 over 2,400 -1. So that would be unit elastic. Okay. So everybody okay with those? So I just gotta write down who got all these points here. And, all right, we can put like the pluses by the names. Just like it would be Jasmine gets a +2. Those guys get +1s. Carrie did a +1. Was it Chanel did the other one? Okay, so Chanel does a plus. This would be Chanel here. That's a +2. So just put
It's
a
a
plus.
+1.
Oh, Marianne, okay, so it's a +1 +1.
Here.
Okay. All right, so, and what else were there?
Somebody found Shaq.
All right, so we're good? All right, so good. The next one, if the company, let's look at number 6. If the company wants to maximize their revenue, then they should set prices where? In which portion? Which portion? The unit elastic was where they will maximize their revenue. Number 7, did anybody get that one? If the price is equal to 50 and the quantity is equal to 60, then total revenue is how much?
3,000.
3,000, and the average cost per unit is 35 to produce, then what would be the profit?
900.
I didn't do it yet. Anybody else get it? Let's make it up before class, real quick. Did anybody else get that? No?
That's how I was
All right.
thinking now.
Okay, so it would be 3,000 is 35 times 60 is, yeah, 35 times 60 is what?
2,100.
And 50 times 6.